Hello and welcome to the course. This is the last segment of our takeoff. This is the Airborne, and in this video we're going to model the Airborne in MATLAB. This is the algorithm, and if you look at this, it is literally about the same with the rotation part. The only difference is the condition here. Now I'm in the MATLAB, so I go down. Here the rotation I have, I simply copy all the rotation segment and I paste it here. Okay, let's change this to Airborne. Let me see that. And let's copy this and paste here. This is also Airborne. And I don't need those settings anymore because the same control logic is the same. I mean, it also applies to Airborne. In here, I need to change this to ZE. That's our iteration. Watch out for the sign convention, and it should be smaller than 15. And finally, I'm not on the ground anymore. So I don't need those expressions anymore. I can delete those. These were for the condition where I'm on the ground. By the way, let's go back to the ground roll. As you can see, we didn't add this condition, this restriction to the ground roll. The reason is during the ground roll, my body fix and my earth frame are identical already. So what I'm obtaining there, the body velocities are actually the earth velocities. Therefore, I have no problem in here. But for convenience, for robustness, you can copy this and paste here. There is no problem. I mean, either way it will work, but let's do this. Okay, I go down. The Airborne is done actually. So if I run the simulation, I should have the solutions. Okay. First, let's examine the angle of attack. As you can see, up to some point, angle of attack start to decrease because angle of attack transforming to the flight path angle. My pitch angle is increased to 20, but we are not on the ground, so it's not a problem. We have elevator deflection going up because we solved this behavior. Actually, we see that the elevator will go positive deflection. We solve this behavior, but it's not a problem. It's not unphysical thing. It's simply trying to adjust the airplane to perform this maneuver. Let's look at the forces. My lift slightly decreases because my angle of attack decreases, but I will keep increase my air speed, therefore there will be no problem. On aerodynamic moments, keep changes its sign, but again, this due to the elevator deflection, we will come to the zero eventually. And the specific consumption, the total fuel, mass flow, they are still increasing. The throttle setting is still maxed. The longitudinal acceleration is keep decreasing. Now we are vertical acceleration because we are increasing our altitude, and as you can see, it is really high. And my ground speed is, we have exceeded 100 meters per second. We have a climb rate right now, which is 15 meters per second, which is also so fast. And combining those, we have the true airspeed, which we have exceeded 100, and the Mach number, we now exceed 0.2. And finally, when we look at the mission trajectory, we see that we take off about 1 kilometer and we increase our altitude 15 meters. And this is the end of the mission. The mission is the takeoff. This is it for Airborne. And finally, let's visualize this actually. I have a separate code for that, which is called as visualization. This is not a technical document actually. This is not a, I mean, you don't have that much technical things in it. Only the, where is it? The matrix here, where, not the matrix, the range calculation here, which is the specific range, and it's calculated for the instantaneous range, and we have the instantaneous endurance formula here. As you can see, I use AI for this because I don't know how to create those kind of things. I mean, these are not technical. We are creating scene setup here. Like I said, we have runway, we have trail, we have aircraft mesh here because I obtained the exact CAD file of the T-38 aircraft from the internet, and I added this to here. We have some geometry. We have afterburners. You'll see. This is so cool, by the way. Twin flames, or and we have hood setup where you can see lots of parameters such as the Mach number, pitch angle, altitude, throttle, reheat, which is the afterburning on or off, specific excess power, distance flown, fuel flow, instantaneous range, and instantaneous endurance are shown in the hood. And as you can see, this is the AI's thing. I mean, they like to add those things. And we have the animation loop finally. I mean, I don't cover this. I will simply share this because I don't even know what's really going on inside this program, let's say, because I totally use AI for this. I mean, that's also. Let's run the code and see our nice visualization. Oh, no, where is the aircraft? Okay, I've forgotten to add the CAD file here, so the this program couldn't read it. So I'm coming back. Here we are. I added that STL file. Now I can run the code again. And here it is. You can see the flames there, which is so cool. And we start from 0, we accelerate, and we increase our pitch angle here, and we take off. And this is because I increased my altitude to 14 meters, which is about 15, so it has ended. I can run the code again so that we can see the simulation. This is so cool. My FPS is dropping right now. My PC is handling to render this, but this is nice. Okay, this is cool. And you can check the parameters here from the file computer. Mach number, pitch angle, altitude. These are great actually. And we are really engaged, and you can see those afterburners. I think this is the most cooler part of the anyways, this is for takeoff. We're going to perform this for climb as well. So you will see the airplane climb as well via this code. I'm going to share this visualization code as well, but like I said, I used AI for this, totally AI. Anyways, this is for Airborne. I thank you too much for attending and watching, and I'll catch you later.